Well, the time has come, the walrus said, to begin our math class. That's not what he said. Close enough, right? We're going to think of many things. Actually, that's actually fairly true today. Just with not a whole lot of people. Why are there only 2 of you? Where'd everybody go? Natalie, what did you do to them? All right, well, the YouTube video is streaming, so they can catch up later. All right, let's go on. Today, we are returning to the tail behavior. Not that we have much to add to it, because I kind of already covered this when I went through everything about polynomials. Right? So, in a sense, we hit it overkill previously. But you'll probably want to dig out these notes because it'll be extremely useful to refer to. And this is the part that your reading from this past weekend focused on was this notation, this limit notation. As x approaches negative infinity, the function approaches negative infinity. Right? And it's just a more specific math notation form of describing what is happening to the ends of our polynomials. Are they all going up, down, as we extend left and right? Okay, so that'll be the basis of your work for today, which is this worksheet, in which you are identifying the leading coefficient. Hey, that's going to be ideally the one in front. Ideally the one in front. I didn't say these are guaranteed standard forms. The lead coefficient is the one with the highest power. And then whatever that highest power is, that will tell you your degree. If it's a power of 3, your degree is 3. Right? And the coefficient would be whatever number is in front of that. So with number 1, the highest power, I've got 2, 1, 0. So the highest is 2, degree of 2. The coefficient on that term is a positive 5, so the lead coefficient is positive 5. And the end behavior is determined strictly by the degree itself and the sign of the leading coefficient as determined by this chart, right, which you should already have. So positive 5, power of 2. So leading coefficient is positive. I'm on this column. Degree of 2, 2 is an even number, so I'm in this region here. Both ends are going upward to positive infinity. So if we swap back the end behavior, we will write that as x approaches positive infinity, f of x approaches positive infinity, as x approaches negative infinity, f of x approaches still positive infinity. If you're a real stickler, maybe we should swap the position of those two. We'll list negative infinity first, because that would be the left side. Yeah, that's marginally better. All right, and those 3 concepts are going to be the majority of your work here on this page: lead coefficient, degree, and behavior. Right. Here again, identify the end behavior, justify your answer. Okay, that's where you would explain, oh, I know it's this because the coefficient is this sign, the power is odd or even. Right? That's your explanation. And then we go graphically. All right, same idea. On page 2, you're dealing with writing a polynomial from scratch that follows these behaviors. Okay? And you can write anything you want here as long as it conforms to these requirements, right? So if I want on the left, so that is to say, as x approaches negative, let me draw, man. Negative infinity. There we go. Okay? That's on the left side. It goes to positive infinity. All right, so it needs to go very far up. So inputting a negative x should, large negative x should give me a positive result back. So what does that say about the odd or evenness of your degree? Right. Always think in terms of whenever we say as approaches positive infinity or negative infinity, this is code for, in my head, I always replace this with what happens when x is 1,000,000. As x approaches negative infinity, think of if x equals negative 1,000,000, what's going to happen? So if I have a higher power, it'd be 1,000,000 times 1,000,000. Well, in this case, it'd be negative 1,000,000 times negative 1,000,000, which would give me a positive 1,000,000, right? If it was to the third power, multiplied by negative 1,000,000 again, well, now I'm back to negative, right? So that's what you're checking here. So that'll tell you what sign you need to put on your lead coefficient, and the difference between the two, how they compare, will tell you the endpoint. The rest of it doesn't matter. You don't even need to put more terms. You could just do y equals positive or negative x to the 2 or 3 power, right? And like that's the bare minimum. That'll cover it. Could even be 1 power. Linear is actually a polynomial, right? Don't worry about adding extra terms to it. That's not going to affect this part. All right, and then from there, sketching a graph, same process. And at the very end, we return to, okay, not quite the very end. End of the second page, we return to the translations, right? How do you translate this graph up or down? I would ignore the actual function itself for a moment, and I would first look at the graph because they provide it there for you, and think visually first. That's my recommendation. I think it would be easier to think visually, how can I move this thing, right? I have this picture, and I want to be able to pick it up and move it around, shuffle it left, right, up, down. We could even shrink it or expand it or whatever to match whatever it is they are asking you to do, so that it has no x-intercepts, right? Think visually first. How can I move this, if at all, if it's possible? And then treat the function just as f of x. I need to take f of x and do what? Subtract 5. Or what? I need to take f of x and multiply by 2. Right? Whatever it is. Think in terms of the transformation to the function first as f of x. Then go and apply that to the actual equation. Because they do want you to write the equation for it. Okay, if I multiply the whole thing by 2, then I'm going to stick this in parentheses, multiply by 2, and start distributing, right? Spoiler alert, that's not the answer here. That's what I recommend you do for that. Okay. And then page 3, determine the degree from factored form. Okay, you're going to have to look ahead and say, if I distribute and start multiplying, what is the highest power I'm going to end up with? Determine that first. Do a little mental check. Okay, if I did this multiplying, what would I get? Okay, that would be the biggest one. All you need to do, you only need to check one multiplication, just the biggest one. Find the biggest one, That gets multiplied by the biggest one in the others. If you have 3 terms, everything's get multiplied together. So I have how many x's here times how many x's here times how many x's there, right? Add them all up. That's your biggest power. Then go ahead and do the distribution. All right. And finally, they're going to write in words how you did that. That's it for today. It starts with end behavior, but really it is almost a full review of polynomials and their major features. So again, refer back to those notes. Are there any questions at this point? No? All right, then you have the rest of the period to work on this. Go ahead and upload your finished product when you are done. Whether you are digitally writing on top of this document, printing it out, or just writing your answers on a separate sheet of notebook paper, that is fine by me. Reminder, test next Friday. Quarter review to be posted tomorrow morning. You have the long weekend to work on that, and we'll go over the answers next week in class, which is only Thursday for you guys because you also have the SAT on Wednesday. I'm sorry about that for the double testing. If that's too stressful for anybody, let me know. The SAT is more important. We can do our test later if we had to. Yes, test next Friday. I'll keep it short. It'll be relatively simple. Don't stress over it that much. Right, I think that's it from me. So I'm going to end the stream here.